All right, gentlemen, I'll be right with you. I'm just everything is still kind of booting up a little bit. Zoom, shut that down. Here, done. Let's see, share my screen. Okay. All right. So, greetings, gentlemen. Let's see. Let me join here. Yep, that's right. Don't connect the audio. Check one other thing. Stay as a participant. That's good. Testing, testing. All right. Okay. All right, welcome, gentlemen. Hopefully, you had a great weekend, right? So, we are here in the home stretch, right? We only have three live sessions remaining. So, we meet today. So, I think originally I had it broken up where we focus on exam 1, 2, and 3. But I realized that this morning that I have a study guide that pretty much covers everything from beginning to end. So for the next, we're just going to focus on the study guide. There's 110 questions. Obviously, we're not going to get through all of those questions. So, 3 days is a good amount of time to be practicing that. So it's just going to jump around randomly. We're going to work on that one assignment, but it covers the whole semester. So we'll review today. And then after today, enjoy the rest of your week because I will be on a Thanksgiving holiday. Maximize, get caught up on work if you need to, but, it's a good idea to try to maximize the time with your loved ones and, go ahead and give your loved ones their flowers while they're alive. You know how that stuff goes. So, and then we'll come back a week from today on Monday, December 2nd. And then we'll continue working on the study guide. And then that Wednesday, December 4th is our last live session. So that's the last day of class. That Thursday and Friday, December 5th and 6th are going to be the reading period. So that's when, I don't think any of your classes should meet during that time. Sorry. And it's an opportunity for you to kind of review and prepare for your finals. And then, so again, right now, I'll be hosting your final. So you can anticipate your final exam to become available that Sunday, December 8th at 11:11, and is due Friday, December 13th at 11:59 p.m. Okay, so that Friday, December 13th at 11:59 p.m. That's the hard deadline for all assignments. Okay, so after that date, everything locks out, and that's it. Idealistically, you want it so that when you submit your final exam, you're done. Like that's everything. So this is a good time to get caught up on missing assignments, things of that nature. If you are submitting like past assignments or redoing assignments to improve your overall grade, I would encourage you to like prioritize your exams because that's where you're going to get the most bang for your buck. And then you can prioritize the homework last because it's going to be a lot of work for minimal points. The idea behind the homework is there really to serve as practice to get you ready for the exams. But then once you have access to the exams, you want to do your best to maximize those scores. If you need help, just ask, right? If you need help with any assignment or if anything isn't clear, you can ask or collaborate. It's okay. We just need that each person submit their own work. Yeah, I can't think of anything else. That's the meat and potato. So we're essentially in the home stretch. Okay. So today we're just going to go ahead and get started on this final exam study guide. So we should have it about here. It's 110 questions. I think it goes over the entire semester. So chapters like chapters 1 and 2, section 3.1 and 6.4 should all be in here. Let me check one more time just to make sure. Back to here, I guess. I just want to make sure. I think I saw 3.1. I want to make sure that I also see 6.4 in there. Also, I think there's a course evaluation. So check your Morehouse email. It's a good idea to go ahead and do that. And then Also, there may be an extra credit opportunity. It's just it depends on if I can do it or not. If I can do it, I will. If it's skews the grades too much, then I won't. But there's a potential extra credit opportunity in the form of your overall MyMathLab score. I'm open to considering, your overall MyMathLab score and scaling it so that it counts as 10% of your overall grade. So the higher your MyMathLab score is, your overall MyMathLab score, then the more potential bonus points you could earn. Potentially, you could earn up to 110% out of 100% with that bonus. Let me see. I just want to see the questions here, and I just want to make sure I see chapter 6 in there. I think that's the only one. It should be. I don't see why it wouldn't be. 2, 3, yes, there. Okay. All right.
Professor C.
Yes.
Approximately how many questions is the final?
I don't know. I mean, at worst, it's similar like to the other exams. Exams 1, 2, and 3 is just from the beginning to the end. At worst, it would be twice as long. So, however long it took you to do each of those exams, worst case scenario should take you twice as long. All right, because that's usually how that goes. Is you're allotted twice as much time for the regular exams as you were on the final. Yeah. So, if the regular exams take you about 50 minutes, the final would take you about 100 minutes. So now ours is a little bit different, because you have access to it for like 5 days, a little over 5 days. So you could actually take it if you don't like the score. You can take it as many times as you like. System is only going to take your best score for those 5 days. So you get a ample opportunity to perform on it. Yeah. Okay. That's a good question. Okay, so let's hop into this study guide. Okay. Let's generate here. Let's start with question 63. You're back in the 60s. It was doing 60s this morning. And then I was like, why are you staying in the 60s? And then it said, okay, well, I'll do 70. Literally the number 70. And then like a couple of questions later, it did 59. I was like, why is it staying around? It's hovering around 60 all day. It's so weird. So this question comes from section 2.1. Let's minimize that. We're asked to match the function with its corresponding graph. I think this is like a quadratic functions. So notice that this function is a quadratic. It's already in standard form, right? So in this form, we can quickly identify the vertex of the quadratic. All right, so this is a times x minus h squared plus k. So notice inside the parentheses, we have the x plus 4. So that means the x coordinate of the vertex is -4. And then the k, or the y coordinate of the vertex, is -6. So again, the vertex should be -4, -6. And so that means it's either A or C. And then we have a positive leading coefficient, so it should open upward. So it should be A by a process of elimination. Again, we have a positive leading coefficient, so that automatically eliminates C and D. And then A is the only one that has a vertex of -4, -6. So with those two pieces of information alone, by process of elimination, I'm just going to go with A, and we're Gucci. Okay. Let's generate 56. Okay. Let's see. 210,987. Here it is. Okay. So given this f of x, find f of 6. This comes from section 1.6. Combining functions and composite functions, right? I was trying to think of the title of that section. I was like, it wasn't arithmetical functions. I was like, that's not it. I was like, it wasn't adding, subtracting. It wasn't saying all that. It was combining functions and composite functions, right? So this open circle, this f of 6, all right? I'm gonna zoom in for a while. All right, so that open circle, that means the second function inside the first function, f of 6, right? So the way we go about this, all right, we write the first function like normal. So we'll just say f of x equals 5x minus 9. Then we go back and replace each x with a blank set of parentheses. Right? We replace each x with a blank set of parentheses. And then we're inside the blank parentheses, we put the second function, right? It just happens in this case to both be f, be the same function. So I'll take some notes here. Let's get rid of this guy. Okay. All right. So now let me start by writing f of x like normal. So I'm just going to write 5x minus 9. Okay. Then zoom in a little bit. Oh, are you throwing a tantrum? You sure? Okay. Let's see. If I go like this and then zoom and then do this, are you going to work? Okay, cool. Okay. So again, we wrote f of x like normal. Then we're going to go back and replace each x with a blank set of parentheses. And then, no, and then, and then, no, and then. I don't know if y'all know that movie reference. I'm showing my age a little bit. But you're a real one if you know, right? So anyway, so we replace each x with a blank set of parentheses. Now, into the blank parentheses, we put the second function. Now, this was actually a little bit different. I'm going to revamp this one. This is fine what we're doing, but I just realized we're evaluating a function. We have f of 6, right? So if we start with the innermost nesting, let me at least write that out. I'm going to abandon this for right now, the way I'm doing it. F of 6. So what this means, let me see, f of 6, the second function inside the first function. So we can evaluate f of 6 first, right? So plug a 6 into f. 5 times 6 is 30. Minus 9 would be what? 21. So that means f of 6 is 21. So now we're going to do f of 21. So the f of 6 was replaced with 21. Now we're going to plug 21 back into f again. What is that? 105 minus 9, 96. Looks like the final result is 96. Okay. Let me recap real quick. So f of 6. So I'm basically working my way from the inside out. So first I evaluated f of 6. I think we got a result of 21. Then we took that and plugged it back into f again because basically, that's what this is saying, f of 6, right? Okay, so that one wasn't too bad. Hopefully we'll get one where I can go with the other details like we had earlier in my earlier group. Okay, let's generate. Let's go to question 28. 28. My brain. So I had an eerie realization. So, like at this stage in my life, I'm basically lactose intolerant. I've been avoiding dairy, for so long. I can't do it anymore. I can't process it. It's just bad. And if I try to eat it, it's just bad. It's like poison in my body, right? So yesterday, I was like, I don't know, sometimes I get nostalgic or, comfort food or whatever. And so I found myself at McDonald's and I got a cheeseburger. So I eat the cheeseburger and I'm kind of waiting for like mucus and things. And then it dawns on me, I didn't get sick or anything. And I'm like, why didn't I get sick? Because I know how my body responds to dairy. And then why I didn't get sick? Because it's not dairy. Right? Allegedly. Because Lord knows if I try to eat mac and cheese, like I got, if it has dairy, my body goes crazy. So I ate that and nothing happened. I was like, oh, that's not cheese. So then if it's not cheese, then what is it? But again, this is just my experience. I'm not saying that it is or isn't. You still got to do your own research and decide for yourself. I just thought it was interesting. That was a realization that I personally had. Maybe it could be the case that I'm no longer lactose intolerant, but I highly doubt it. All right, I don't think that's the case. So anywho, I can try eating something else and see how I respond. But yeah, so it's a good chance that that's not actually cheese. So anywho, use the graph to find the indicated value of the function. Okay, so we have a graph. So okay, when x is -3, what's the corresponding y? We're just gonna look at the graph here. So you can see if you start at the origin, you go left 3, and then you go up to the graph, so that corresponding y value looks like it's a positive 1, right? That's just reading a graph. So at this stage, it shouldn't be too terribly bad. Okay, hopefully. That came from section 1.3. Okay. All right, let's generate. Let's go to question 47. 47. All right, sure. Okay, begin by graphing the absolute value function and then using transformations of this graph to graph the given function. Okay, so this is transformations. This comes from section 1.5, transformation of functions. I know that section 1.4 was a library of basic functions or a library of parent functions. So this one is transformation of functions. When we were doing transformations, we had a total of 10 transformations, right? So if those aren't like readily available on the forefront of your consciousness, it's a good idea to go back and review this section. A brief synopsis of transformations. Typically inside manipulations cause horizontal change and now the reverse of our intuition. Outside manipulations tend to cause a vertical change and they go with our intuition. All right. So if we start with the absolute value of x as our base function, when we're doing multiple transformations in one go, we work our way from the inside to the out. So absolute value is a v, that's where the vertex starts at the origin. We got that -1 on the inside. So if we track the vertex, that -1 should go to the right by 1. We multiplied the outside of our base function by negative. So it's like our y values go from positive to negative. So again, we have the v, it started at the origin. The vertex started at the origin. We went right 1. We flipped vertically over the x-axis. And then we went down 2. Okay, so it looks like the only one that did that is A. C and D have the wrong orientation. They're opening up where they should open downward. And I think A is the only one that went right 1 and down 2. So I'm just going to go with that. Okay. So that was transformations. With something like that, suppose you just didn't remember the transformation or you weren't confident in the transformations, you could just, graph it yourself. Choose several values of x, find the corresponding y's, plot the points, and then see which one matches which graph, right? There's more than one way to go about these, right? Okay. Generate. 85. 85. Let's go here. Oh, ho, ho. I think I'm experiencing the itis. I don't know. I always get sleepy. It don't matter whether I eat or I don't eat at this hour. I had to take naps. But I know that that's partly because I'm up like all night every night. Like I'll wake up about 3 or 4 and I'm up till about 5, 6, 7. It was worse when I had to punch a clock because that still would happen. And then I wouldn't fall asleep until maybe 10 minutes before my alarm went. I was like, oh, I'm finally sleepy. I go to sleep and then bam, bam, bam. I was like, ah. That used to happen all the time. And I would be struggling. And then until I just decided to abandon punching the clock, like, as best as I could. Okay. So let's see. This comes from section 2.3. Okay, so that was polynomial, quadratic. What is this one? Okay, yeah. So use the factor theorem in synthetic division. So polynomial long division. Okay. All right. Use the factor theorem in synthetic division to define whether the second polynomial is a factor of the first. Okay. So if we're going to do the factor theorem in synthetic division, basically, if we do synthetic division with the potential 0 in the chair, do we need any placeholders for? We don't need any placeholders because every power is accounted for. So if we do synthetic division, if we get a remainder of 0, then it is a factor. I should take some notes. I'm just trying to find a way to bypass it, but I don't have any place to type here. Okay, so what I'll do, I'll do something like this. Okay. So if we want to know if x plus 4 is a factor, then the potential zero in this case is going to be what? Negative 4. I know that might be a little bit hard to see. Then we take our coefficients. Again, we don't need any placeholders because every power is accounted for. So if we take the coefficients 3, 10, -7, 6, and 8. 1, 2, 3, 4, 5, okay? So again, that first one just comes down. On the diagonal, we multiply, we get -12. We add, we get -2, 8, 1, -4, 2, -8, and indeed we get our 0. So then, is it a factor? We would say yes, because we got a remainder of 0. Okay. Generate. Okay, let's go to 89. Now this is what? 85, 6, 7, 8, 9 is right there. Okay. Find all rational zeros of the given polynomial function. Okay, let's take some notes on this one. So we're going to be applying like multiple techniques here. Rational zero test to generate a list of possible rational zeros. Synthetic division to test whether these are rational zeros. We might even look at the graph just to quickly find the zero. So we're going to be using multiple techniques here. Let me start by getting a copy. You guys excited about your holiday? I'm always excited about these holidays. Like, I don't know, I never get used to it for whatever reason, and I always enjoy them. And I tend to experience senioritis every semester. Where I'd be struggling. I'd be like, man, I just want to just beat myself. I'm gonna let that one be. Okay. That's decent. All right. So let's start off with the rational zero test. So the rational zero test is going to be like what our P over our Q. Did I do that backwards? I don't know. Where P comes from the factors of our constant term, so that's going to be the -30, right? So we can do plus or minus 1 and 30, 2 and 15, 3 and 10. Let me see. 4, 5, and 6. Two and 15. Man, this is a lot. And then 1 and 30. Okay, we got fortunate because the leading coefficient is a 1. So this is actually our list to test. I think that I'm actually just going to go ahead and look at the graph. Instead of guessing and checking to find that first zero, I'm just going to go ahead and look at the graph. This one. Dawn is like losing her mind in the other room. Periodically, she just like starts like chasing her tail and stuff. She starts growling like she's funny. Normally she's asleep at this time. All right. All right. Anywho. Okay. All right. So let's go to our y equals. Let me see if I can type this. That'd be nice. Let's see. Hat 4. Withdraw. 2 tilde hat 3. 2 tilde. Nope. 2 tilde hat 3. Okay. Withdraw. 34 tilde hat 2. 34 tilde hat 2. Okay. Withdraw. 67 tilde. Withdraw 30. Okay. I'm just going to look at the graph. So let me see. X to the power of 4 minus 2x cubed minus 34x squared minus 67x minus 30 graph. Okay, so we can see several zeros. See now, if I were guessing the check-in, I would have started with 1, and that is not a confirmed 0. It looks like we might have an irrational zero in there, but I think they only want the rational zeros. So it looks like the simplest rational zero. It looks like we have two irrational zeros actually. It looks like the simplest rational zero might be that -2. It looks like -2 and -3 are our rational zeros. So let's start with -2 to confirm or deny whether that is indeed one of those zeros. There we go. So we're going to start with -2 just because of the graph. Okay. So let's start with -2. Again, we didn't need any placeholders. So we just take out 4, 3, 2. So we take the coefficients 1, -2, -34, -67, and -30. Okay. So we want to see if we get a remainder of 0. So then the 1 comes down, -2, -4, +8. Let me see if there were 10. Over here, -4 would be 30. So -26. 52, 14, 15, -15, +30, and indeed we get our 0, right? So we found one of our zeros. Now I'm just pulling it straight from the graph. We saw that it looked like it also crossed at -3. So we're just going to go ahead and test -3 here. Okay. So if -3 is one of our zeros, okay, so we're going to do synthetic division, -3. So again, the first one just comes down. Oops. So then diagonal, we multiply, we add, +21. What is that, a -5, +15? God is good. All right. So because we got a remainder of 0 there, we can confirm that -3 is also a 0. Let me see. We started with a degree 4. So then at this stage, it was a degree 3, right? So that means at this final stage, we're now at a degree 2. Okay. And we have our two zeros. So then if we put all this together, if -2 is a 0, the factor takes on the form of x plus 2. If -3 is a 0, the factor takes on the form of x plus 3. Right? And then we still have this x squared minus 7x minus 5. Are there two numbers? See, and we don't have two numbers that multiply to give us -5 and add to give us -7. So those zeros are going to be irrational. They're not going to be rational. Let me see. What did the question request? It said find all rational zeros. It didn't say find all zeros. It said find all rational zeros. So the two rational zeros that we have are the -2 and -3. Those other two zeros are irrational zeros. So -2 and -3. Bark, bark. She is hilarious. Oh man, -2. And then like she's so funny. Like when I let her out, and the neighbor dog comes out at the same time. He's a small dog too. He's a Pomeranian. Pomeranian. I think that's what they're called. They're these little dogs. They're like fluffy, and their ears look like butterflies. So I guess it's like French for like butterfly. And so she loves him. She just like, oh, she's like, oh hey, how's it going? And she's just like all full attention and excited to see him. It's so funny. It's hilarious. Anyway, okay. All right, let's keep going. What's the time? Okay, cool. We got a solid, just shy of 15 minutes. Generate, let's go to question 53. What question? That was 89. 53 is the key. Okay. So now we're combining functions and their domains. Okay. So one thing off the rip that we can notice, f is what, a quadratic, so its domain is all reals. G is a cubic, so its domain is all reals. So then all of these cases, again, provided we're not dividing by 0 for that division one, all reals intersection all reals is all reals. So most of these domains are going to be all reals. We'll explore when we get to division, when we get to that one, what happens, right? So if we say f plus g, if we combine like terms, there really aren't any. So we're going to finish with x cubed plus 5x squared minus 5x plus 5. So many fives. Okay. The domain we said was all reals. And again, the way we got that, the domain of f was all reals, the domain of g was all reals intersection all reals was all reals. F minus g. Okay, so we got lucky we don't need to distribute. So I'm going to type it. Let me get rid of this. We're still doing this thing. Okay. So f minus g, I'm going to type it as like negative x cubed and then plus 5x squared minus 5x plus 5. I just rearranged the order. Commutative property of addition. Okay. Domain, it should still be all reals. F times g. Let me see. F times g. So we're going to distribute the x cubed. Let me see. We're going to get what? 3 plus 2 is 5, right? 5x to the 5th. 5x to the power 5 minus 5x to the power 4 plus 5x to the power 3. So now, when it comes to these review sessions, right? Because I have my 9 o'clock group, I have you all, and then I have a 3 o'clock group. All of you all are like College Algebra 1. It doesn't hurt to go back and watch the one from this morning because the questions that they went over are essentially different from what you all do. And, the ones I do with my 3 o'clock are going to be different. It's going to be like some similar, and many of them are different. Ooh, the Christmas Carol. Save the date. Yeah, these are actually kind of fun. Yeah, if you haven't experienced like the Morehouse Glee Club and the Christmas Carol concert, I just got an email. This is the 98th annual. Wow. So they're almost to 100, 2 years. It says December 6th. I don't know if you need tickets or anything. You probably don't. But it's free, right? Yeah. So it's something to check out. It's a lot of fun. You might catch me there. Maybe. Might try to bring a friend or two. Anywho. Oh, yeah. It's a good idea to watch the recordings from my other groups as well when it comes to these review sessions. Because I do random questions from the same study guide. So to get more exposed to more of these questions, if you view theirs, you'll see more of it. If you're open to that. Domain should still be all reals. Because I definitely did not do this with my earlier group, and there are definitely some questions I did with them that I would like you all to have access to. That it may or may not pop up. F divided by G. Okay. I think I'm gonna just leave it separate. So F is 5x squared minus 5x plus 5. And in the denominator, I'm going to leave it as x to the power of 3. Now, we're still doing all reals, intersection all reals, but we also have to factor in that we can't divide by 0. So I think the value of x that makes the denominator 0 is going to be 0. So we want all reals except 0. And that's captured by C. So that's the only stipulation there. Again, whenever we're working with fractions, you got to keep in mind that we cannot divide by 0. Okay, that was a funky little adventure. Let's generate. Let's go to question 38. I think my dog heard me talking about her, so then she stopped. Now she's just like looking out the window and things. She knows what I'm talking about. It's so funny. Sketch the graph of the function shown below. Okay, so this is a piecewise function This comes from section 1.4, library of functions. And then find a domain and range. So when x is between is greater than or equal to -1, but strictly less than 1, we have the absolute value of x. So that should just be a v. You're gonna have a closed circle on the left and an open circle on the right. Actually, I think it's gonna get filled in by the square root function. So it normally would be an open circle on the right, but it connects with this function here. So then we have the square root function, but we only apply it when x is greater than or equal to 1. So I think that the one that makes that shape is C. Is C, right? Between -1 and 1, we have our V, we have our closed circle on the left. And again, the circle gets filled in because of the function on the right, or the bottom function. All right, so I'm gonna go with C. The domain, so the far left would be what? -1 to positive infinity. And I think we do include -1, so it's going to be a square bracket. The range is the very bottom to the very top. So the very bottom, I think, is 0 to infinity, which is this guy. Check. That's it. Let's go to question 93.
Got it.
Okay. Oh, where'd it go?
All this money.
Yep.
All this money.
All right. Okay, use your knowledge of transformations. Maybe I could just do a long stream. I don't know if I want to do that. Yeah, maybe. I don't know. We'll see. Use your knowledge of transformations to compare the graph of the function given below with the graph of this. Okay, so this is transformations. Let me see. This is actually from exponential section 3.1 exponential functions, but it's applying the concept of transformation of functions. So 4 to the power of x, the general exponential function, to the far left, it approaches 0. As we go to negative infinity, it passes through the point 0, 1, and then it blows up to infinity on the right. So then if we say a +3 on the outside of our base function, that's going to move the entire graph up 3 units. So it's the graph I just described, just moved up by 3 units, and that's it. So the exponential function is third row left. I'm just clicking randomly on the graph. Our base is already set to 4. We said we moved it up by 3. 1, 2, 3, right there. Do they want, let me see, graph the given function? Sometimes they want the horizontal asymptote. I'm going to try this first. If we get an error, I'll go back and add the horizontal asymptote. Okay. It's sometimes, right? Okay. All right, not too bad. Let's generate. Let's go to question 60. Yeah, I used to use Google to generate, but sometimes, obviously Google can't hear me properly, and it goes sideways. It eats up too much precious time. So that's why I used to give me a random thing. Okay, express the function as a composition of two functions. This comes from section 1.6, combining functions and composite functions. So we want to decompose this function into 2 separate functions. Now, one potential inside function could be that x cubed minus 6, right? Like as listed in B. Let's see if B works. And then the outside function is going to be 2 over the absolute value of x. That looks good. All right. There's more than one correct answer here, so we just need one correct answer. Okay. Okay, not too bad. Let's generate. We'll go to question 34. There. Now, I know I mentioned that mini story about the cheeseburger. When I was eating, I was like, okay, I'm gonna see how I feel the next day after eating this. And sure enough, now I didn't get my usual lactose response, but I do have this like lagging headache, and I feel like my energy is low. I feel lethargic. It's a noticeable difference after eating something like that. I was like, yeah, no, I'm struggling here. I'm struggling. So even though I didn't, and the fact that I didn't have that lactose response is still really off-putting to me. Again, in my psyche, that says, hey, that's not cheese, because I didn't have that. So that lactose response. So only reason I would be eating it is like comfort food, but then I already know that it's gonna make me feel worse. I already know how I feel afterwards. Like I'm always like, okay, how do I feel after eating this? If I don't feel right, I try to get it out of my diet. I don't usually eat that, but sometimes we're all spiritual beings having a human experience anyway. So, okay, the table is a complete representation of f. Decide if it's even, odd, or neither. Okay, let's review real quick. We got a solid 2 minutes. The definition of even and odd function. The definition of an even function: when we evaluate f of negative x, we get back to the original. Let me say that one more time. The definition of an even function: when we evaluate f of negative x, we get back to the original. The definition of an odd function: when we evaluate f of negative x, we get negative times the original. Let me say it one more time. For an odd function, when we evaluate f of negative x, we finish with negative times the original. Okay. Even functions have y-axis symmetry. So whenever we have x comma y, we also have negative x comma y. So notice the y values stay the same, but the x values are opposite. With an odd function, we have origin symmetry. So whenever we have x comma y, we also have negative x comma negative y. So they both change, right? When we look at this, it looks like only the x values change. Notice those y values stay the same. So if we were to plot these points, it looks like they're going to be symmetric about the y-axis, right? Notice only the x values change, but the y values stay the same. So that's an indication that this function is even. Okay. If the function were odd, not only would the x values change, the sign and the x values would change, but also the sign and the y value would change as well. Okay. All right, guys, that's essentially time. Yeah, so just happy holidays, enjoy your break, and I will be back 1 week from today. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, happy holidays and see you in a week. Take care, gentlemen. Peace. I'll stay on the call. Yep. I'll stay on the call because I meet with another group in like 15 minutes. So if you have questions, I'll be here. I'm going to mute myself. So actually, I think I'm gonna do my little. What time is? I got like 15 minutes. Oh, I know. One time I did like a Easter egg, so I'm gonna do the same Easter egg. I'm gonna do a brawl. Sometimes it crashes on me, but I'm gonna just do a brawl. Not a full match. Full match I need like 30 minutes, and I don't have. So I'll do a shorter match. I might do a second short match and dip out on them. I might have to abandon them. I don't like to do that because if I leave, then they're gonna be shorter player, and my account might get like locked or whatever. But yeah, I'm gonna just do this to fill the space. Just as a little Easter egg. So again, this is a game called Mobile Legends Bang Bang. It's a 5-on-5 battle royale. Normally the matches take like 30 minutes. I'm going to do a shorter version. Now, they got different modes in here that are actually kind of fun, too. Let me see. Do they have any arcades available? Ends in 2 days. What's Death Battle? Oh, it opens on Monday. I don't know what that is. Let me see. Is this open now? Play different heroes in a single match. I don't know what that is. I had to check that one out. But I'm going to do a brawl. Brawls take about 10 minutes. I got 15 minutes, so I might be able to get 1.5 hours. So with the brawl, it's basically the 5-on-5. It's just 5v5, one lane, and you just go in. Ranger, these are decent people. I'm not good with Ranger. We got Moscow. She's good. Let me switch with this. Okay. Ooh, Johnson, but I don't think you really need him. We got a mage. I think I'm gonna go with him. Let's see if we can find this. No. Okay. Yeah, I'm gonna go like this. All right, let's confirm. I'm gonna need healing. I'm gonna do. Excellent. So I was gonna do healing. So if I can purchase her mana rapidly, like off the rip, that'll be much better. I don't really know how to use this character. I just know that if you use her right, she can be really powerful. We got a lot of damage going. Oh, they got Saber. Ooh, my brain. Yeah, I'm realizing that this is the repercussions of that burger. Like I was like, why have I been having a headache all day? And it dawned on me, it's like it's definitely a cheeseburger. Okay, so let me go here and buy this off the rip. Purchase. Nice, that's the hardest one. And I'm gonna teleport. Let's just go. Actually, let me get closer.
5 seconds till the enemy reaches the battlefield.
Get closer. These are.
All troops deployed. Let my will bend the earth.
Go. Gotta keep hitting it. One more. Run. Nobody came up there. I was like, come on, guys. You have to see me up here. And he hasn't even moved. So we're short a guy. Whew. He's about to die. Oh.
An enemy has been slain.
Run.
Let my will bend the
You
earth.
shadow coats. Oh, they trying to clap back. Nice, get him, coach, get him. Yeah, they got me. Run.
Your life but I will take any.
That's not good. Got another one. I gotta run though. He got me. That's okay. This is a brawl. This isn't a normal match. You don't have like access to everything. So you just do the best you can. I'm just gonna get behind them.
Never look back if you got
He might
nothing
get
to
me.
regret. Double kill. Let my will bend the earth.
Dang! Didn't even get him! I tried, but I knew he was back there. Okay, I need where is it? Magic. This one. Yeah, I need this one.
You are failing the Oriental warriors.
Got him, coach.
Double kill.
Granger, go. That's why I gave him, because like I knew how powerful he is. And I was like, somebody can.
Everyone has the right.
Oh my god, run! Come on. Pick some of these guys.
Ally has been slain.
What's the mess with him?
Loneliness never bothers me. Let my will bend the earth.
Right.
The future of of Cadia Riverlands is in our
Nice.
hands.
He is just like all over it. Ooh, run! Run! He is not playing around. Oh, I gotta run. Okay, cool. At least I got my little thing here. I think I'm gonna do some healing. Defense. I'm not really doing damage. So can heal. What's the time?
Never look back if you have
Our
nothing
turret
to
is
regret.
under attack.
Let my will bend the earth.
Shut down. Our turret has been destroyed.
Nobody's there. Like they just chilling. Hit him. There we go. We just got the kill. I don't get it. You need to try, brother. Nope, he's there. Nobody. We got 2 marksmen. Okay, I'm gonna try to get behind him again. 8 seconds.
Like a string puppet, you are totally under my control. Let my will bend the earth. Ah!
So you kind of got to keep pressure on them. You got to just keep trying. I don't know if die.
Down. Double kill. Ally has been slain. An enemy has been slain. Ally has been slain. Enemy double kill.
Dang, I know it's wrong. That's okay.
Wiped out.
All right, I am trying to heal. Still got a ways to go.
Long.
What's the time? We got 5 minutes. Harley, I'm gonna put Harley behind him. His food. Cause he just been sitting there. I don't even know if he's gotten into this match. Next one, I want this one.
The future of Cadia Riverlands is in our
Oh, he left. He's
hands.
paying attention.
Let my will bend the earth.
I knew that they were gonna chase me, so I was like, you know what? I'm gonna just blast. Over me! That's okay. Oh, they don't listen. Okay, cool. Harley was paying attention. I don't think he was paying attention. I was going to sacrifice him, but I got sacrificed. Oh, okay. Let's go. Let's go. Uh-oh. Yeah. Whoosh. Go, go, go. Oh, my goodness. He died. Come on, Green.
Let my
Hey.
will bend.
Come on, guys. Like, why are y'all so passive? Like, I need y'all to get... I gotta go. Yeah. I only got like 5 minutes. I gotta go. It's taking too long. That's not the right chord. Oh. No, I don't want that one. I want yeah, we're about to lose. Like they keep just running back and forth. They're not trying. Savage. What time is it?
Where we
I got like 2 minutes. All right. I'm gonna get rid of this. I'm gonna go more defense. Yeah, I don't know. They were too passive. It's okay. It's a brawl. That's how the brawls go.
Under attack.
How they go? What's the time? Alright. 2 minutes. We had them for a little bit, but they stopped. They just stopped trying. I was like, bro, you got to keep going. They don't let you do 3 now. Come on. Low skill level and taking the beat. Let's go with this. It's fine. All right. Let's get this back on track. Audio is good. Screen share is good. So we got 2 minutes. Let me hop here. Let's get rid of this. Go back to my courses. Feel like I got my second win. This one, 3 p.m. So like my study. All right, we still got a minute. Sure, that'll be nice. I'm gonna just use the tarp, I guess. With the tarp, but I have it drag it. Seconds. All right. So greetings, scholars. Let me see. Okay, so welcome. Hopefully everyone had a great weekend, right? And let's just do our synopsis of the remaining schedule. So today we're going to be focused, just reviewing for the final. After today, we're off for the rest of the week for the Thanksgiving holiday. It's a great opportunity to get caught up on some work and maximize some time with like loved ones and try to give your loved ones their flowers while they're alive, right? You know what I mean? Don't wait until tragedy strikes to, tell them how you feel about them, right? As long as it's instructive. If it's destructive, then possibly keep it to yourself. My mom would say, if you don't have anything nice to say, don't say anything at all, right? But yeah, so we'll be off for the Thanksgiving holiday for the remainder of this week after today, and then we'll come back for Monday and Wednesday of next week. We're just going to be reviewing the final. That Wednesday next week on the 4th, that's our last day of classes, so that's our last live session on next Wednesday. And then Thursday, December 5th and 6th, Thursday and Friday is the reading period. I just got an email a moment ago about Morehouse Christmas concert. It's a free event. I think it's like the 6th through the 8th or the 6th and the 8th, something like that. So if you've never experienced it, it's definitely a sight to see. It's something that's interesting. It's free. So just check it out. So yeah, the reading period is December 5th and 6th, and then you can anticipate your final exam to become available on that Sunday morning, December 8th at 11:11 a.m. And it's due that Friday, December 13th at 11:59 p.m. That Friday, December 13th at 11:59 p.m., that's the hard deadline for all assignments. All right, so shortly thereafter, we have to calculate final grades. Yeah, so idealistically, you want, when you submit your final, you want that to be the last thing and you're done. So this is a great opportunity to get caught up and submit, like, boost old scores or whatever. If you're going back and submitting and boosting those scores to increase your overall grade, I would encourage you to prioritize your exams first, because that's where you're going to get the most bang for your bucks. And then prioritize the homework last, because that's a lot of work for minimal points. Everything, even including the finals, are limited attempts, and the system is set to take your highest score. There's no, you can't submit the final past the hard deadline, though. So nothing like that. And then there's a potential extra credit opportunity in the form of your overall MyMathLab score. So the higher your overall MyMathLab score, the more potential extra credit that you can earn. I'm open to the idea of like scaling your overall MyMathLab score so that it counts as 10% of your overall grade, provided that it doesn't skew the grades too much. So that's something that would be automatic. On your end, I'm just letting you know, if you want to maximize that, then you would maximize your overall MyMathLab score. And then also, I think there are course evaluations. So just, I think that's in your Morehouse email, so check that, and it's there. As usual, if you have questions, feel free to keep them to yourself. I'm kidding. Feel free to put them in the chat or unmute yourself to get my attention that we could talk about it. And let's go ahead and just hop into the study guide. So initially, I was going to break the study guide apart into, per exam, like focus on exam 1, 2, and 3. But then I saw this document that pretty much had everything from the beginning to the end. I was like, okay, but we can just use this over these 3 days, and then this will work too. All right, so the more time we can spend on this, the better. Let's go ahead and generate. We'll start off with question 90. We'll start off with question 90, which is the key. Okay. Okay, let's minimize this. So this comes from section 2.3, polynomial long division and synthetic division. Here we're asked to find all rational zeros of f. Then use the Depressed equation to find all roots. Okay. So in other words, they want us to find all the zeros. All right. So let's take some notes here. I'm going to get a copy of this, a screenshot. We're going to drop this. Right there. And so basically, I'm combining the notes from all of my classes into just for today into just one long PDF. It's also a good idea. So with today's recording, well, you all's recording is typically attached to my 2 p.m. because you guys talk about the same thing. But with these study guides, all the different sections go over different questions. So it's a good idea to watch the one from the 2 o'clock, which is attached to yours on my channel, and then maybe the one from 9 o'clock this morning as well. In the effort to just get a more comprehensive review, right? Because again, each section goes through a different set of questions from the same study guide, so more or less. Okay, so here, let's start off with the rational zero test, okay? That's gonna be the whole P over Q business, right? So that's gonna be like our P over our Q, where P comes from the factors of our constant term, which is 52, okay. What is that, 26? So then we can say, now this one's a little bit more involved. 1 and 52, I think it's what, 2 and 26, 4 and 13. So let's do 4 and 13. I think that's it, right? So we said 4 and 13, 2 and 26, and then 1 and 52. So it's 2 times 2 times 13. And then the denominator comes from our leading coefficient, which is a 2. So this is going to be plus or minus 1 and plus or minus 2. So then what we would do, we would essentially do all combinations with the top, with the thing on the bottom, with no repeats, right? So this is a list of our possible rational zeros. We got the 1, 2, 4, 13, 26, and 52. And then if we divide each by 2, we get a half. 2 over 2 is a 1. We've already done that. 4 divided by 2 is 2. We've done that one. So 13 over 2. 26 divided by 2 is 13. So we've done that one. And 52 divided by 2 is 26. So we have that one as well. So this is our list of possible rational zeros. So I think what I'm going to do, I'm going to just look at the graph to find that first zero, or that potential first zero. How can I separate this? Okay, that'll work. I'll work with that. And let's go to our y equals. So 2 to the hat 3, 2 to the hat 3. Withdraw 4 tilde I. Nope. Yeah. Withdraw 26 tilde. Okay. Addition. That was over here. 2. Okay. 2x cubed minus 4x squared minus 26x plus 52. Okay, I'm just going to hit graph because I'm just trying to find a zero to investigate. It looks like what? 2? It looks like 2 is the only rational one. Oh, wow. Awesome. Nice. All right. Okay, so let's verify whether or not 2 is indeed a 0. So that's just looking at the graph. So then if 2 is our potential 0, it goes in the chair. 3, 2, 1, 0. So we don't need any placeholders because every power is accounted for. So we just take our coefficients: 2, -4, -26, and 52. Okay. So then the first number just comes down. Diagonal, we multiply, we add, we multiply, we add, we multiply, and indeed it is a 0, right? So we confirmed that 2 is our 0. If we started with a degree 3, at this point, we're now at a degree 2. So we have 2x squared minus 26. Can we factor that? So let me see, if 2 is our 0, then the factor takes on the form x minus 2, and then we have this 2x squared minus 26. Okay. With this second factor, if we set it to 0 and solve, add 26 divided by 2, we have x squared equals what, 13? So then x equals plus or minus the square root of 13. So those are our irrational zeros. It's about 3 point something, right? Because the perfect squares is between 9 and 16, right? So it's 3 point something. So plus or minus 3 point something. Okay. So we got what? 2 and then plus or minus the square root of 13. The set of all zeros. Okay. Type in exact answer using radicals as needed. Okay. So that's a good omen. We got 2, comma, plus or minus the square root. T. Okay. Plus 13. Nope. Try again. 13. Darn it. It's tripping today. 13. Okay. All right, let's go with that. Okay. All right, let's generate. Let's go to another random. Generate. That's fine. 89, the one before. So this comes from section 2.3, question 45. Find all the rational zeros. Okay. So similar deal as the previous. Let's just go ahead and get a copy. We can do it right there, there, right there. Okay. Drop. Yes. Right there's fine. Cool. All right, let's go. Okay. Find all rational zeros of the given polynomial function. Okay, so let's just do the same thing we just did. Where's my pen? Let's start with our rational zero test, our P over Q. So we said our P over our Q. So the P comes from the factors of our constant term, which is 42. What is that, 21? So 3 and 7. Okay. So plus or minus 1 and 42, plus or minus 2 and 21. 3 and 14. 30 plus 12, yeah. So 3 here. So I'll do better with this. So like off to the side, I'll do my 42. We said is what? 2 and 21. But 21 is 3 times 7, so those are my factors. So then let me see, 3, 4, 5, 6. We can do 6. Okay, 6 and 7 are 2 in the middle. So then 6, and you have 7, 3 and what, 14, 2 and 21, and then 1 and 42. Okay, so those are the factors of our constant term. Oh, praise the Lord. I was like, if that leading coefficient is anything other than 1, then we're gonna have like a whole bunch of numbers to go through. We got lucky, right? We're blessed because the leading coefficient is a 1. So because that's a 1, this is our list, right? We got lucky. Okay. So now these are not the actual zeros. This is our list of possible rational zeros. Okay. So then what I like to do is just look at the graph, just in the interest of time, instead of doing all this guessing and checking. We have these tools, just use them. Like, you know, why not? What? That's not the right one. How are we to go? Okay, so I'm going to go to my y equals, if it works. Okay, clear. Ho, ho. Let's type this bad boy in. Tilde hat 4. Withdraw. 4 tilde hat 3. 4 tilde hat 3. Withdraw. 46. Tilde hat. No, instead of tilde hat, let's do I. Okay. Withdraw 89, tilde, withdraw 42. Okay. So x to the 4 minus 4x cubed minus 46x squared minus 89x minus 42. Okay. So I'm just going to hit graph. See where it crosses. Okay, we got several. So it looks like the first rational one, it looks like -2 and -3. It looks like there's a fraction one. Maybe that's irrational. I see a couple of irrational. So let's test -2 and -3. They look like potential zeros. Okay. So we'll start off with -2. So instead of guessing and checking, we would have tried 1. We would have tried -1. We may have possibly tried 2. You see, that's 3 times doing synthetic division that we can bypass. So let's start off with -2 in the chair. Do we need any placeholders? All right. Power 4, 3, 2, 1, 0. So every power is accounted for, so we don't need any placeholders. So then we take our coefficients 1, -4, -46, -89, and -42. Okay. So again, the first number just comes down. Diagonal, we multiply. We get this, -6, +12. It's going to be -434. 46, okay. 68, +68. It's going to be a negative. 9 minus 8 is a 1, 21. 42, +42, and indeed we got our 0. Okay, so we confirmed that -2 is a 0. We also suspect that -3 is a 0 from the graph. So I'm going to do synthetic division with -3. Okay. So again, the first number just comes down. Diagonal, we multiply, so we get this. We add. 9 times 3 is what, 27. 3 and 4 is a -7, +21, and indeed we got our 0. So that checked out as well. Okay. If we started with a degree 4, then at this stage we were at a degree 3, the depressed equation, right? If that's degree 3, then at this stage we're at a degree 2 polynomial, right? So if we put all this information together, if -2 is our 0, then the factor takes on the form x plus 2. This other one takes on the form x plus 3 times x squared minus 9x minus 7. Now, since we got that down to a quadratic, we can use a quadratic formula to solve that quadratic to find the zeros. We can do completing the square. Let me do completing the square real quick. So I'm going to add 0. I'm just focused on that trinomial. The leading coefficient is already a 1 there, so that helps out drastically. -b over 2a. That's going to give us weird fractions. Let's just go with it. So then -b, no, b over 2 squared, right? I think I'm mixing up my formulas. B over 2 squared. I think it's b over 2 squared. Plus or minus, right? So b over 2 squared. We're going to say plus and then minus of b over 2 squared. Okay. So that will be what? 9 over 2 squared? 81 over 4? Man, I'm not liking this. We could use a quadratic formula too if this gets to be too hairy. 81 over 4 and minus 81 over 4. And then the minus 7. So let's just keep going here. If we focus on the first 3 terms, right? Can we factor them? 9 over 2. I think it's going to be x minus 9 over 2 quantity squared. Let me see. 7 towards the 28. So 109, a negative 109 over 4. Let me see. 18 divided by 2 is indeed 9. I think this is okay. So if we set this guy to 0 and solve, we have this x minus 9 over 2 squared, 109 over 4. You take the square root, x minus 9 over 2 plus or minus square root of 109 over 2. And then add. So it looks like it's going to be 9 plus or minus the square root of 109 all over 2. Those are the irrational zeros. Now we could check. Let's see how to check this. So for instance, if we put that result into the original, so that was completing the square, that may not have been the easiest route. We possibly could have also done quadratic formula, but I just wanted to kind of keep going with it just to kind of challenge myself. But now let me verify if this is a zero or not. So I just want to evaluate this function. At these values, right? So when x is, let me see, we're gonna say 9 minus the square root of 109. Close off the numerator, divided by 2. We should get 0 or something close to 0. And then if we change that from a minus to a plus, and that's essentially 0. That's like 3.6 times 10 to the negative 10. So we have like 9 zeros in front of that. So that's essentially 0 as well. So it's close enough. Okay, so I know that was a little bit finding the zeros. Now again, we did complete the square. You didn't have to do it that way. We could have also done quadratic formula, right? The negative b plus or minus the square root of b squared minus 4ac all over 2a. We could have done that as well. Okay. All right, so let's submit these results. We're gonna hop over here. There you go. It's a little bit better. Is that gonna work? The rational zeros, yeah. Oh, see. So we didn't even need the irrational. It just wants the rational zeros. They didn't want the irrational. So once we had -2 and -3, we were actually done. So we just did a little bit extra. -2, -3. Yeah, it's okay. Reading is fundamental. Reading is half the battle. All right. The more you know. And knowing is half the battle. G.I. Joe. Okay. All right, so that was good. Let me see. Let's keep going. Generate. Let me get rid of this for now. 61. Okay, we'll go ahead and do 61. Right there. This comes from section 2.1, I think polynomial functions. Maybe not. Identify the graph of the following quadratic function or quadratic function. I think 2.1 may have been quadratic function. So notice that the leading coefficient is negative. So that means the quadratic should open downward. So it can't be B or C. So we can eliminate those off the rip. You can say that it's in standard form so that the vertex should be at the origin, right? And I think D has been moved, so the vertex is not at the origin. All right, so we would go with A. Let's go to question 25. The domain, okay. So for a function like this, right? In general, for a rational function, the domain is all reals except any x that makes the denominator 0. There's an added stipulation that we can't, for the inside a radical, an even root, we can't take the square root or an even root of a negative. So the inside part has to be greater than or equal to 0. But again, it can't be equal to 0 because it's in the denominator. So that x minus 5 has to be strictly greater than 0. So if we add 5 to both sides, x has to be strictly greater than 5. Okay, interval notation. So strictly greater than 5 is going to be double parentheses, 5 to infinity. So like if we choose a number like 6, when x is 6, 6 minus 5 is a 1, square root of 1 is 1. 3642. So we get a real solution. But if we choose a number like 4, right, we should get a non-real solution. 4 minus 5 is -1. Square root of a negative is imaginary. So no real number, right? So we just chose a few test points to confirm that this indeed works. So we're going to go ahead and submit this. And we got that it worked. Let me just check on you guys real quick. Let me see. A game show that Arcane was based. Oh, really? When you came in, I didn't know that. Like, I thought it looked similar. I don't know. That's a good question, actually. I just checked the chat. It says this is the game show that Arcane was based off of. I think there's a show on like Netflix called Arcane. I've noticed it, but I've never watched it. And so, you know, I had that little Easter egg. It's called that was Mobile Legends Bang Bang. So I don't know. It could be. I'd have to research that to see if they based that show on that game. Okay, let me see. 25. Did we do 25? We did do 25. Generate. Did we do 80? I think we did something in the 80s a moment ago. Okay, we'll do 80. So this question comes from section 2.2, question 43. For this function, answer the following equation. Answer the following. Describe the end behavior of the function and sketch the graph. Okay. So if we want to explore the end graph behavior of this function, it's a good idea to expand this out. If we do that, we'll see that the leading term is going to be negative 6x to the power of 3. So that means that we'll have a negative leading coefficient, which means our graph should fall to the right. And the degree of this polynomial is going to be a 3, which is odd. So that means the other side does the opposite. So in the long term, the graph should fall to the right and rise to the left. Rise to the left and falls to the right. So then B, right? Check. Okay. So that's end graph behavior. And then sketch the graph. Okay. So I'm just gonna use my polygon tool or this polynomial tool. I'm just gonna click on 4 random spots. I'm just gonna go 1, 2, 3, 4. Okay, so then I'm gonna come back. Now we already have this in completely factored form. All right. So for instance, when x is -1, we should have a 0. So I'm just gonna drag this guy. Let me just type it in. -1, that's fine. And then this one needs to be 0. Okay. So we know when x is -1, we have a 0. When x is 0, we have a 0. So I'm just going to choose a second point, and it should pass through the origin. Submit. Okay. Let's try when x is 1. Let me see. 1 plus 1 is 2 times 6 is going to be a -12. So when x is 1, we're at -12. So I'll put this one at 1, -12. And then we need one more. Let's try -1 to see if that works. It should bounce. The origin has an even multiplicity. It should bounce at the origin. Something's off. When x is 1, yeah, we get our -12. -1 should cross. I think I might need. Let me see if I do a half. Let's see. Do we get a negative? That's positive. That's positive. It will be negative. When x is 0, passing to the origin. That should bounce off the x-axis. It has an even multiplicity. Let me try let me try negative 2. So when x is negative 2, that's a negative. Let's see. That's a positive 4. Okay. 6 times 4 is 24. It goes off the chart. So that was negative 2. Why does this feel off? Okay, we just need one more point. So I think negative 2 went off the chart. Only thing that's just kind of throwing me off is the multiplicity. When x is negative 1, we get our 0. That should cross, though. I think negative 2 goes off the chart. It's just not behaving the way. I'm missing something. Oh, you know what? No, anyway. Let me try a negative 1.5. Okay. When x is a negative 1.5, that's a negative 1/2. That's going to be a positive, whatever number that is. It's going to be positive. Okay. Negative 1.5. That's a negative 1/2. Okay. Hey, Google, what's negative 1/2 times negative 6 times negative 1.5 times negative 1.5?
-1 divided by 2 times -6 times -1.5 times -1.5 is 6.75.
I don't know if she said that right. I'm going to use my calculator. We're just trying to find that last point. Let's go here. We just need one more. Hang on. Let's go here. I'm going to use this instead. Come on. Okay. Now we could just look at the graph too. You know what? Since we have it, let's just do that real quick. So we got this negative 6 tilde I. Okay. Parentheses tilde plus 1 close parentheses. Okay. I mean, it is kind of behaving properly. I don't know. Oh, it needs to be down. Yeah. Yeah, that's exactly. Okay. Okay, so yeah, this is the image. I was like, it's supposed to bounce at the origin and cross at negative 1. So we need like when x is a negative 1/2. Let me see. When x is a negative 1/2, matter of fact, I'll just use this to find the corresponding y. So I want to evaluate this function when x is a negative 1/2, negative 3/4. Okay. Okay, so that's our final point. Negative 1/2, negative 3/4. So this guy right here, we need to edit. And right here. Actually, that negative 1/2, and then negative 3/4. 0.75. Okay. So again, the struggle we were having, we had to find one additional point to get it to behave properly. We found one, and now it's behaving properly, right? Because I was also anticipating, I was like, it should bounce at the origin and cross at negative 1. But again, we weren't seeing it because we didn't have all 4 points in there. Once we got all 4 points, it started behaving the proper way. This looks good, so I'm going to go with it. Okay. So again, we started with the intercepts. Like when x was negative 1, we knew that was a 0. We knew that the origin was a 0. And then we tried 1. I think we were able to get 1 on the graph. And then for that final one, we had to do a negative 1/2. You had to choose like the right one for it to work, right? And so we found one that worked, got it, and we typed the point in. So yeah, that was it. Okay, so that was fun. We got 10 minutes left, right? Let's generate. Also, it's a good idea to watch the recordings from earlier today, because I have 2 other sections at 9 o'clock and at 2 o'clock. You know, you all are kind of studying the same stuff, but everybody's going over different questions. It's the same study guide, but in different questions. So, you know, it's a good idea to, watch those recordings for a more complete review. 64. So I personally have been doing this all day, but I know for you all, we only meet for like 50 minutes. I find a quadratic function that has this vertex whose graph passes through this point. Okay. In standard form. So I'm going to take some notes here, right? The standard form of a quadratic is a times x minus h quantity squared plus k. So that's the standard form of a quadratic. Taking notes here is not the best, but we're gonna kind of work with it. So our h and k is the origin, so those kind of fall off. And it passes through that point, so we don't know a, but when x is 3, so then 3 squared is going to be a 9. It should equal negative 18. So then it looks like our a equals negative 2. So I'm going to finish it out here. So if a is negative 2 and we put it all together, we're going to have negative 2 x minus 0. So it's just going to be x squared. That's it. Because k is 0 as well. Okay. So let's see if this works. So when x is 0, the corresponding y is 0. When x is 3, 3 squared is 9 times 2 is indeed negative 18. So then, yeah, we can be confident in this. So again, we use the standard form of the equation of a quadratic. They gave us the vertex and they gave us a point on the quadratic. So we plugged in the h, k, the x, and the y, and then we solved for a. We got the a was equal to negative 2. You know, yada, yada, yada. Okay. Okay. I got something in my eye. And it's so weird, like rubbing my eye was like making me drowsy. I was like, oh, that feels so good. I just wanted to like go to sleep. I don't know why that's so soothing, but it is. Okay, anywho. All right, let's generate. Let's go to question 105. Right there. Solve the following system by elimination method. See, I think you all are the first ones to get one of these solving the system of equations today. Well, actually, my other group had one that was pretty interesting as well. I had to look it up in the split second because it was like our very last question. Elimination method, right? Let's take some notes. I mean, so what we would have to do is multiply. If we multiply equation 1 by 9, we're going to have 9x and a negative 9y. When we add them together, the variables are going to cancel. So on the left, we're going to have a 0, and 9 plus 2 is 11. We're going to finish with 0 equals 11, which is a false statement. So that means that these should be two parallel lines with different y-intercepts. So there should be no solution. It should be the empty set. Again, I started to write it out, but you quickly can kind of see if you multiply that first equation by 9, all the variables cancel, and we finish with a false statement. So that means it was no solution. Generate. Let's go to 56. Here. Given this f, okay, f of 3. So composition of functions, one function inside another. So this is basically the second function inside the first function. So if we start with the second function, we're just going to evaluate f of 3. So we're going to plug in 3 into f. 5 times 3 is 15 minus 8 is what, 7? Okay. Then we're going to take 7 and plug it back into f. So then 7 times 5 is 35 minus 8, 30, 28. 28. So then f of 3 looks like it's 20 rows. Let's try it again. So 5 times 3 is 15 minus 8. It should be a 7. 7 times 5, oh, it's a 3. So we put 28, so it should be 27. I think I subtracted 2. Let's try 27. Okay. All right, let's see. We've got a few minutes. Let me see, generate. Let's go to question 81. right here. Using data division and to find the quotient and the remainder when the first polynomial is divided by the second. Okay, so let's write this one out. Actually, yeah, no, we should write it out. This will be our last one for the day. Once I get it. Cut. All right. So first polynomial divided by the second. So if x minus 2 is our factor, our potential 0 is a 2. So 2 goes in the chair. Do we need any placeholders? The powers go 5, 4, 3, 2, 1, 0. So we don't need any placeholders, so we just take the coefficients. 1, 2, -7, 2, 1, and -1. The first number just comes down. 2, 4, 8, 1, 2, 4, 8, 9, 18. And it looks like we finished with what, 17. Okay. 14, 14, 9, 14, 14, 9, 17. 14, 14, 9, 17. 14, 14, 9, 17. Come on. 14, 14, 9. Okay, let's go back. So now we started with a degree 5. So then at this stage it was a degree 4. So x to the power 4 plus 4x to the power of 3 plus x squared plus 4x plus 9. I mean, obviously we don't need those one coefficients. Let's just go with this. We might need to change that remainder. We're going to try this first. Okay, that works. Okay, gentlemen. Are there any burning questions before we go our separate ways? Let me see. So just, if there are any burning questions, we're going to go ahead and end the session here. Enjoy happy holidays, and we'll meet back in 1 week, same time, same place to kind of wrap everything up. All right, gentlemen, happy holidays and take care. Safe travels, and see you next time. All right, so I'm going to suppress this for now. Well, I was going to go ahead and do your attendance, but it won't let me while I'm still logged in. So, all right, gentlemen, safe travels. Good luck with everything.
Thank you.
This is a game show. Oh yeah, we talked about that.